All right, today we are talking about circles. So we have some information about a circle. We want to find the standard equation. Standard equation requires two things, the center and the radius of a circle having these 2 points as endpoints of a diameter. So again, the endpoints of a diameter thing means that if I connect those with a straight line, then that straight line is the diameter of the circle. And if you're thinking, man, what a good circle, you're right, that is a really good circle. Now I put a graph here with, it's nice and tidy and has grid marks and all that kind of stuff, so that I can draw on things without it being too, awful looking for the video. But don't uh, don't mistake what I'm doing for relying on the graph. I'm going to work out what everything is. I'm not using the graph to decide what these points are. So you don't need, like a nicely drawn version of this on graph paper or a ruler or a compass or whatever to do what we're about to do. So I'm going to connect these with a straight line. Again, we got to find two things. Let's start with the center. The center is the midpoint of that line. And the way you find the midpoint is by taking the average. So the point in the middle is going to be the point that's halfway in between in both the left right sense. It's going to be halfway between that way and also halfway between that way. So to find the x coordinate, what I'm going to do is take the average of the two x coordinates I have. The way you average two things is to add them together and divide by 2. So 1 and 7 is 8, divided by 2 is 4. If we're talking about 1 and 7 and finding what's halfway in between, you can even think about it as just sort of counting in from both ends, and 4, makes sense as the answer there. And then I'm going to do the same thing with the y values. Average them. I have -2 and 6. I'm going to add those together and divide by 2. It's 4 over 2 is 2. And again, halfway between these two, 2 makes sense, right? It's in between, and you can count out from either one and get to 2 in the same way. Okay, so our midpoint or our center is the 0.42. Since I have the graph here, I'm just going to mark that 0.42, and that looks like it's halfway, right? Again, I'm not using the fact that it looks halfway as meaning that it is halfway. I've just worked out that it's halfway, and okay, great, it looks right also. So it's more of a check than a method for finding it. Okay, the radius. Radius is a distance. Specifically, the distance from the center. So what I want to know is how far this is, or how far this is. They're both the same. That's how circles work. So pick one. Let's use this. It doesn't matter. I want to know that distance. I'm going to label that R for the radius. The way I'm going to find the distance, there is a distance formula you can use. I can never remember it. I can't really, but I don't like the whole formula thing. But the way I can go diagonally is to think about it as going up and over, right? The same way that you would like count slope, right? To get from here to here, we go that way, but the way you go that way is to go up 1, 2, 3, 4, 5, 6, 7, 8, and over 1, 2, 3, 4, 5, 6. So up, sorry, let's use an actual pen, up 8 over 6. Now counting up and over, and I labeled them over here, but it's the same thing, up 8 over 6. Counting up and over means that I'm defining a right triangle. So looking at either of these two triangles I've just drawn, we'll just stick with one of them. what I know is the Pythagorean theorem. Says that the sum of the squares of the sides is equal to the square of the hypotenuse. So in our case, 6 squared plus 8 squared equals r squared. 6 squared is 36. Oh, goodness gracious. You silly goose. Hey, did everybody catch what I did there? And how I can't count? So I counted grid lines. And hey, look, this is a place where like having the graph actually kind of goofed me up a little bit. That's 5, 6, 7. This is actually 1, 2, 3 over, and 1, 2, 3, 4 up. Okay, my bad. Idea is the same. I just counted wrong. But if I'd actually been counting rather than looking at my graph and thinking about how I get from 4 to 7, 4, 5, you can't see me counting on my fingers, but I'm counting on my fingers. 4, 5, 6, 7 is 3. And from 2 to 6, 2, 3, 4, 5, 6 is 4. So again, having the graph there actually kind of messed me up. Okay, so over 3, up 4, so 3 squared plus 4 squared, 9 and 16, which is 25. So r squared is 25. That means that r, the radius, is 5. Actually write radius. Is 5. Okay. I'm also going to make this S look like an S. There we go. Radius is 5. Okay, so the center is the 0.42. The radius is 5. The equation of the circle in standard form looks like this then. In here, we put the x coordinate as the radius, and if you want, you can think of that as a shift to the right by 4 from the origin. So x minus 4 squared, plus similarly for y minus 2 squared equals the square of the radius, so 25. That's the equation of the circle. Oh, and I could do this. That'd be fun. X minus 4 squared plus y minus 2 squared equals. Now what we should see is that this circle has the two points that are marked on the boundary, so on the circle itself, and kind of across the like widest part. So there you go. They're directly across from each other with the center at 4, 2. Okay, cool. So that's circles. Hope that helps. Please let me know if you have any questions. Otherwise, I will see you in class.